Okay, so welcome to the second session of BW for HANA training. We just completed the pre-session questions and answers, and now we are starting the main class. And today we are going to look at native HANA modeling. That's where we will start with. So we will not jump to BW for HANA modeling right now. So we will start with native HANA modeling because every BW consultant should know the basics of native HANA modeling because that's an integral part of most of the developments which I have seen. And you will have to know what is a calculation view. You have to know how to consume that in a composite provider. You have to know how to consume a table in a BW for HANA, so on and so forth. So that's why we are starting with the native HANA modeling from very basic. So this will give you the necessary background and the knowledge for working with native HANA models. Now, many of you, for you, this might be very basic stuff. You have already worked on it. So I would request you to just bear with us because there are some people who have never worked with native HANA modeling and some people who have limited knowledge. So we'll go a little bit slow, not so slow, but a little bit slow in the sense that I will explain from scratch everything, and then we will pick up pace from there. All right, so the requirement is that we have to create a calculation view for material dimension, plant dimension. We have to create a CV for sales fact, which is your transaction data. These are your master data. This is your transaction data. And then finally, we'll create a calculation view, which will combine the master data and the transaction data, meaning your plant, material, and sales will be combined into a final CV calculation view. Then we will also look at, while we do this, we will also create table functions to see how table functions have replaced the script-based CVs and what is the syntax to create a table function. And finally, we'll also create a database procedure to see that at the end, if you want to schedule a bunch of SQL statements, how you do that in native HANA. Okay, and later on, if time permits, I'll also show you access job. Access job is basically the job control which is used to schedule these DB procedures on a daily basis. So if you want a job to run like just like a process chain in BW, we have access job controller in native HANA, which is used to schedule these database procedures on a daily, weekly, or whatever frequency you want. So we'll look into that. Okay. So step number, please remember the steps I'm going to ask you, okay, when we do the development. Step number one is we'll have to create a remote source, smart data access remote source. We will create it. Usually it's a basis job, but because we have access in the system, I'm going to show you how you can create a remote source so that you have the background. If there's any problem, you can work with basis and you can help them troubleshoot the issue. So you should know how to create a remote source, and that remote source will give us the ability to create virtual tables. So we will create virtual tables based on that remote source. That's our step number one. Then we will go on to create calculation views based on those virtual tables and staging tables. So I just forgot to mention virtual tables and staging tables. So we'll create both types of tables, virtual table and my staging table. And I'll tell you the reason why staging tables are required. You can have a CV directly on virtual tables, that's possible, but usually because of performance reasons, we materialize the data into staging tables and then we use them in the calculation view. So that's what we are going to do. And then step three will be, I'll show you how a table function is used, what are the scenarios in which you have to go for table functions, and then step four, DB procedure, step five, access job if time permits. All right, so let's delve into the system. Actually, you know what? Before I go into the system, I'll quickly give you a short theory about smart data access and what is a remote source, and then we will go into the system. Because if you understand this, then you will be able to understand better what I'm doing in the system and why I'm doing that. Okay. One more thing, guys. I would request all of you to go on mute. I'll take the questions in between and then at the end, of course. But let's be on mute while the session is going on so that the recording is clear. All right, so what is smart data access? Smart data access is a technology based mostly on ODBC drivers, which enables remote data to be accessed, meaning you don't have to persist the data in your HANA database. Using the smart data access ODBC drivers, you can virtually access the data from any external database. It supports most of the frequently used databases and some others as well. So SAP has given drivers out of the box to enable the connectivity to those remote databases. And what are the steps you have to do to make sure SDA is installed? So there are a few steps. The first, guys, can you please be on mute? Humble request. Thank you. So the step number one is you have to install the ODBC driver for the remote source database. In our case, it is already given. So a lot of the drivers are already given out of the box. You don't have to do that. But if you find a database for which you did not find an appropriate driver, then you have to install the ODBC driver in your HANA database. Once that is done, then you will create a remote source with a user ID which should have required privileges. So there are some privileges for you to create a remote source, system privileges. So you should have that. Once you have that, you will be able to create a remote source which points to the remote database. Then we will create a virtual table based on the remote source.
Did you brush your teeth? Did you brush your teeth?
Milk from guys, can you please be on mute?
Only one bottle, okay?
We can still see some, we can still hear some feedback.
Then bring another one.
Is it, okay, thank you. Yeah, so then we will create a virtual table in the target HANA database. Once the remote source is done, then we will create a virtual table. And by the way, I have brushed my teeth in the morning, so I'm good there. So then we will create a persistent table. This is an important step from a performance standpoint. So when you have a virtual table in the HANA database, you are accessing the data virtually. And if the data set is small, if it is, the volume is less, it will work well for you. But the moment the data goes to millions of records, then you will start seeing degradation of performance. And that's why virtual tables are recommended for small data volume. If you have larger data volumes or if you have growth in your data, then you should create a staging table and materialize that data via virtual table into staging tables, which we are going to do today. And then you have to use that in the calculation views. Then once the virtual table is done, you will create a persistent staging table in the HANA target HANA database, okay, usually required for performance reasons. But again, I'm telling you, this is not a mandatory step. You can use virtual tables directly in the calculation views. That's possible. And then finally, we create a calculation view on top of either the virtual table or the persistent table. So these are the steps which you have to take in order for you to configure SDA and then start using the SDA. So as you can see in the diagram, our scenario, what we are going to do here is from BW's HANA database, we are going to access S4 HANA's HANA database tables. So for us, the remote database is S4 HANA's HANA DB. Of course, that doesn't happen in real time. In real time, you will have remote databases like Teradata or Hadoop or Sybase IQ or other databases. But since we don't have that in our landscape, I'm going to show you the same functionality from the S4 HANA's HANA DB. So that's going to be our remote database. Okay. All right. So let's jump to the system. Let me close all this. Okay. So when I'm talking about HANA database and smart data access, you will not do that from the projects here because this is the application server connectivity. So if you have to create a remote database, you have to create virtual tables. We are talking about a database level activity. So what we'll do is we'll have to go to the development perspective or modeler perspective and connect to the database directly. So that's what I have done here. I'm switching here because I have to use VDI. As I mentioned yesterday, the ports are not working, so I cannot do it from my local Eclipse. So I'm switching to VDI. And here I have my BW for HANA's HANA database added and S4 HANA's HANA database is added. So these are all database level. Okay. So now the first step, what is the first step? Can anybody tell me what is the first step?
Creation of remote RDC.
Creation of remote source.
Yeah, remote
So
source.
how do you, can anybody tell me where do you create a remote source?
The
In HANA?
provisioning.
In
Correct.
provisioning.
Yes. In provisioning, you will go, and when you expand provisioning, you will have smart data access here, and there is a folder which will be remote sources. So if you expand this, if you already have that, that's fine. We are going to create from scratch. So you right click on the remote source and you say new remote source. When you click new remote source, you will see some details you have to fill. What is the source name? Source name is nothing but a user given name. So any name you can give. So what I will give is, since we are connecting to S4 HANA, so I'll give S4 HDB underscore BT2. BT2 is for batch 2. So because I already have for batch 1, so I just want to differentiate from that. So I'm just giving S4 HDB BT2. So let's remember this name. This we will use that later on. So I'll copy this name. Okay. Then the adapter name. Adapter name is the ODBC driver which you have to use. So if you expand here, SAP has given already out of the box ODBC drivers for many databases or most frequently used databases like your Teradata, your IQ, your HANA, Hadoop, generic ODBC, Oracle, MS SQL, so on and so forth. The one which we are going to use is HANA ODBC. Why? Because we are connecting to S4 applications HANA database. So the driver will be HANA ODBC. Then the source location should be index server, which is the only choice, because index server is the main server inside the HANA database. There are multiple servers, but index server is the main guy. Then automatically some fields will be populated: adapter version, properties, data source name, etc. You don't have to do that. What you have to start from is server name. So you should know the server name. So in our case, the server name, let me see, what is the server name? So I'm using the get trained. So this is the S4 HANA server name. Okay, so I'll just paste it here. So it is s41909.gettrain.com. This is a fully qualified host name of the server. So you should get that from your server vendor, whoever you are using. They should give you the fully qualified host name for your server. And the port is the ODBC port for HANA is the default port 30015. That is usually the default port. But if it is configured differently in your server, please get that port number from your server vendor. So in this case, the host name of the server, port number I have given. DML mode, data manipulation mode, is read only, but you can change it to read write. There are two options. So we'll go for read write because we will be dealing with the virtual tables, creation of them, deletion of them, so on and so forth. So we'll go for read write. Then extra adapter properties you don't have to provide, that's fine. Then you'll have to give a technical user ID and password. Why this is required? Can anybody tell me why this is asking for a user ID? I am already using user ID BW for user. Then why it is again asking me for a user?
Because
Anyone?
it should be a DB user with the S4 HANA, right? This you should give this the S4 HANA DB user here.
That's right. This is not my BW for HANA user. This is a user ID who or which should have access to HANA database of S4 HANA application. Why? Because when I will try to create virtual table, the communication will happen via this user ID. So please make sure that this user ID should have enough privileges to create tables, to do a select from table from HANA database of S4. So this is an S4's user ID, not BW's user ID. So as you can see, the technical user ID which I'm using right now is SH9 user. And then the password you should know, you can get that from your server vendor. So I'll just give the password here. Hit enter. That's an important step. Don't forget to hit enter. Only then it will be accepted. So let's review that. So source name is this, adapter name HANA, index server. This is my qualified host name, port number, read write, SH9 user. Yeah, it's correct. And it's okay. So once you are making, you make sure that all the details are correct. Then you click on this green symbol which says save this editor. Once you save it, it will say remote source created, connection to remote source established. This is a message you should receive. If there's an error, you will receive the error that, there is some issue, not able to access, invalid credentials, something like that. So you have to make sure all these values, the details are correct. Once it is correct, the remote source will be created and the connection will be established. Now you can see that we have a remote source created, S4 HDB BT2. If you don't see that, you can just come here and refresh. And once you refresh, you'll be able to see that S4 HDB BT2. Now, if you expand this, this is called remote source. So we have created a new remote source using smart data access technology, ODBC drivers. Now, if you click here, the first thing you will see is null. So that is by default with all remote sources, the first database symbol or the database connectivity is null, but don't worry about that. That's default. Once you expand that, you will be able to see all the schemas. These are schemas. Now, every schema is also a user. So that's why you will see the user symbol, but these are also schemas. Now, which schema is the S4 owned schema?
SAP HANA DB.
Correct. SAP HANA DB. This is my S4 owned schema. That means the application server S4 HANA is the owner of this particular schema, and all the S4 tables, your AC Doka, your Mad Doc, your Mara, your VBAP, your VBAK, all the tables will be housed in this particular schema. Guys, can you please be on mute? And there's some feedback noise in the background. Thank you. Okay, so this is the S4 owned schema. All our tables will be here. So remember that we will use it. So what is the step number 1 is done. Okay, remote sources created. What is my step number 2?
We have to create virtual tables.
Exactly. Now we have to create virtual tables. So to create virtual tables, you need a schema because all the tables are housed inside a schema. So now the work is done with provisioning folder. You can minimize that. And then now we will go into catalog. Catalog folder stores all the tables, including virtual tables. So first step is we have to create a schema. So you have to open your SQL console. Okay. So we will write some SQL script code and we will create the schema and we'll create virtual tables. So we will not do it graphically. We will do it using SQL statements because some things are not possible graphically. Some things are possible. So for this, we will use a SQL statement. So to open the SQL console, you can click on catalog or you can click on any schema here. And this particular symbol, open SQL console, should be activated. You click on that and your SQL console is there. Now you can start writing your SQL script codes. Okay. So first thing is we'll create a new schema. So I'll say create schema. And then in double quotes, usually we use double quotes because, it can be case sensitive. So we'll always use double quotes and we'll give in uppercase. I'll just type Debanshu SDA because we are creating virtual tables. So I'm going to use the name SDA and BT2 for batch 2. Semicolon. All the SQL script statements should end with semicolon. Okay, that's the syntax. So create schema. As you can see, it came in a different color. And the table, the schema name came in a different color. The object names, the database objects will come in blue and the keywords will come in different color so that you can easily identify. So I'm saying create schema, this. Again, your user ID should have enough privileges to create a schema. There's also a separate system privilege you have to have. If you don't have that, you will not be able to create a schema. So make sure whatever vendor you're using, you have the necessary privileges. So I'll just click on execute here, F8. So it says schema created successfully. Okay, I just want to make sure you guys can see the messages at the bottom. Can you guys see the message?
Yep.
Statement
Yes.
create. Okay, perfect. Now I will refresh here my catalog. Okay, I'll just refresh and I should see a schema called Debanshu SDA BT2. Yes, the schema is created. Now the tables are not there. It's an empty folder. That means no tables are there. Now I'll start creating my virtual tables. Okay, not my persistent tables, but virtual table. So the syntax to create the virtual table is create virtual table, simple syntax. Okay, and then you give the name of the schema and then the table. The format is first you have to give the schema name and then the table name. Now, either you can type the schema name completely, or what you can do is you can just type the few letters like DEB and hit Control Space. The moment you hit Control Space, that is a shortcut to get the list of all the objects which starts with the same naming convention as you wrote, 3 letters, DEB. So our schema is this guy. There's another way to do this. Okay, the another way is drag and drop. So if you want to drag this particular schema, you can drag it and put it on the SQL console. That will also bring your schema name. So whatever way is convenient for you, you can use that. So we'll say create virtual table dot the table name. So we'll give the table name as VT because I want to differentiate the virtual tables with the other tables. So I'll just give VT. VT stands for virtual table. And we'll start with Mara. Okay, Mara is the master data table for material. Okay, so Mara is a master data table for material. And the way you have to write a comment here is either double dash or the multi-line comment starts with slash star and ends with star slash. This is another way to write comment. So if you have a multi-line comment, you will use this. If you have a single line comment, you can use double dash to do the comments in SQL script console. So we'll say create virtual table Mara this, okay, at. So this is the special syntax for creating virtual tables. At what? Now you have to give the full path. So what is my path? You go to provisioning, remote source. This is S4 HDB BT2. So I will just, let's see if I can drag it here. No, drag is not working for virtual things. So we'll just type it, that's fine. So S4 HDB BT2, okay, dot. Then what is the next navigation step here? The navigation step next is null. So we'll have to put null here, null. Then what we have to put, what is the schema name where Mara is stored? SAP HANA DB. That is the S4 owned schema. So we'll give SAP HANA DB. Okay. And then finally the table name, which is my VT underscore.
I guess it should be Mara, right? Or
sorry, my bad. It should be Mara. Yeah, you're right. And then semicolon. So what it says is create the virtual table with this name and create it from the table Mara, which is stored in SAP HANA DB under null under this virtual source. So this is the syntax to create virtual table. Okay, let's run this. So it's trying to create here, as you can see the progress bar, and it says virtual table executed or virtual table create statement is successful. So that means we created a virtual table which will access the data from the Mara table in runtime. It will not store the data. So let's quickly see if our table is created. So you go back to catalog, go back to this table and refresh here. Okay. Once you refresh, you will see a table. You should see a table created by the name of VT underscore Mara. There you go. And you see a small green pipe symbol. This means that this is a virtual table. The normal tables will not have this green pipe symbol. Only the virtual tables will have this. And also you can see the remote source through which it got created. So this is the way you will create the virtual tables. Now, what is the next step? We'll create a staging table. Okay. So one more thing. As a best practice, you also create drop table command before the create table. Okay. So I'll write that. Debanshu this. Why I'm doing this? Because I can reuse this. So whenever I want to reuse something, I'll just drop and recreate. Usually you will not drop the virtual table. Okay. You will only drop virtual table when there is a change in the structure of the table. But just for demonstration purpose, I'm just showing you that you can also do a drop, which makes it reusable, so that every time you run the script, it will drop it and it will create it afresh. So you can do that, drop table. And then what we will do is same thing we'll do here. We will copy this. Okay, we'll paste it. Now we are creating a staging table. So now I'll say, instead of VTA, I'll say STA. STA stands for staging. And here also I will say create. Now there is no virtual table. This is not a virtual table. This is a column table. So when you create an actual persistent tables, you have two options. Either it can be a row table or it can be a column table. Usually in HANA, 80 to 90% of the tables are column tables. Row tables are only system tables. There are some system tables which are created as row tables. So in our case, we are going to create a column table. So we will create with create column table command. And then I will change the name here, stmara. And then what I will do is, as now I'm not creating with a virtual table, so I'll say as and master data of material, master data staging table, and this is master data virtual table. Okay, so I'll say as select star from this virtual table. So now I will say this virtual table, whatever I created, I'll give a, I'm selecting everything from the virtual table and I'm actually materializing it into my staging table. Okay. So first step, what did we do? We created a virtual table from the remote source. First step done. Then now we are materializing the data from the remote source via virtual table into my actual staging table. So now I'm actually persisting the data in my staging table. Why I'm doing that? I don't have to do this. This is not mandatory, but for performance reasons, you will usually have to do that once the volume grows. That's why I'm showing you how to do that as well. So let's do this. Drop table should fail because there is no table. So it failed. That's fine. Now we'll create column table from Mara, and that should bring in the necessary records from Mara into the staging table of Mara. So it's running right now. Okay, so it completed successfully. Rows affected 2557. So now let's refresh our table folder again. Once you refresh the table folder, you will see that now there is a second table which should come up. Yeah, there you go. So this is a column table. Just by the symbol also you can make out that this is a column table because column is highlighted here. So now we can do a data preview quickly. Right click on the table, click on data preview. You will be able to see the data successfully got materialized. Okay, we have 2557 records. Also, if you want to check from the virtual table, you can also check from the virtual table open content. Now, when you say open content from the virtual table, you are actually asking the virtual table to go to Mara in real time in S4 and get the data. So this is virtual access. Okay, that's why it was a slightly slow than the actual staging table data preview. But virtual table can also be directly used in calculation views. So this is how we created the virtual table for Mara, and then we created the staging table for Mara. Now we'll do this for all other tables. There are a bunch of tables. So what I'm going to do is I'm going to copy the remaining code just to save time. So I already have the code there with me. Let me open that file. Okay, so there you go. So what I will do is from this line onwards, I will just copy the code. Okay, just to save time. It's the same syntax what I did. Okay, let me select all. Okay, we'll come back to our SQL console, which is this one. And we'll paste it here and we'll remove the redundant ones. So let's review this. So we have the SDA BT2, we have VT Mara staging table is done. Okay, this is not required. Mara we have already done. So I'm going to remove the redundant code. Okay, create column table ST Mara is done. Now the same thing is being repeated now for MAKT, which is the text table for material. We are doing the same thing, virtual table and staging table. For T001W, which is for plant, this is plant details, the S4 table for plant. So we are doing that. Then we are doing for address table, the address of the plant. Then we are doing the AC DOCA, same thing, virtual table and staging table. We are doing VBAP for sales details, and that's it. Right? Create. This is test one. We don't require. So I'll remove this. Okay. Now I need to change the schema name, right? Because the schema name here says Debanshu underscore SDA, but the new schema which we created is Debanshu SDA BT2. So what we'll do is we'll copy this. Okay, we'll copy. We'll select all. Then we will replace. So I'm going to replace Debanshu underscore SDA with Debanshu underscore SDA underscore BT2. So it replaced everything. Okay, let's do a cross check just to make sure syntax is correct. See here what happened, BT2, BT2, because we already gave BT2 for that. So that's why let's remove this BT2 twice. Okay, and remaining thing should be fine. Debanshu underscore SDA. Now you can use the double quotes, or you if you don't use the double quotes, then it should all.
BT2 is repeated.
Sorry, are you seeing anywhere else?
In the schema
table.
Create schema.
Also, the S4 HDB we need to mention as underscore DB2.
Oh yeah, the remote source name, correct?
Right.
Yes, yes, you're right. Thank you for that. Good catch. Good catch. Okay, let's remove that. I mean, replace that as well. So we'll replace S4 HDB to S4 HDB BT, sorry, BT2. Again, I think the first one will be BT2 twice. Okay, remaining should be fine.
In the schema name, the first line, create schema.
Yes. Correct. Anywhere else, guys, are you seeing any issues? SDA BT2, BT2, SDA BT2, BT2. Yeah, should be fine, right? Now, these are the set of SQL statements we created. But say, for example, if you want to shut down your work right now and you have to come back again tomorrow. So again, you should not write all these statements. So there are two ways to save. You should save this set of statements so that it is reusable. And tomorrow when you come back to work, you should just open the file and all the statements should be there with you, right? So the way you do it is, there are two ways. One, you press Ctrl S and you can save it on your local machine. That is one way, okay? So either you can create it like this, S4 HDB, I'll just change the name, BT2, okay, .SQL. This is on my local machine, in my local machine folder. This is what you can do, step number one. Or what you can do is, if you want to save it on a server itself, then what you can do is, you can copy this code. So I'll copy everything, select all, I'll copy it. And now what I will do is, I will go to repository. Instead of system, I'll go to repository because I'm creating a file now on the server. So on the server, it is always a repository, server repository. And there I will create a new schema. Okay, not new schema, package. I'll create a new package. Okay. So I'll say new repository package. And I will give the name Z Debanshu BT2. Okay. I click on next. Everything is fine. Default. Oh, the language was German. I will change that later. Now a package is created. So in the system, you create schemas, but in the repository or in the content folder here, in the content folder here, we create packages because the calculation views, the procedures, table functions, these are repository objects, and the repository objects are always created in the package. So they are arranged in a package. So I've created a new package, Z Debanshu BT2. And now what I'm going to do is, I'm going to right click on this. I'll create another package. Okay. And that package will be for my SQL scripts. So I'll say package. So SAP HANA repository package, Click on next. Now the package name should be SQL scripts. Okay, click on next. Let's change the language to English. English United States is fine. And then everything else is fine. I'm not giving delivery unit because I'm not going to transport this. I'll discuss the delivery unit later on. Now a new package is created, SQL scripts. Now I can right click here. I can say new and I can say other. And in other, just try to find file. Okay, just a general file. So you can click on general file. You can give the name, maybe we'll give virtual table creation.sql. Okay, don't forget this extension. It should be .sql, virtual table creation.sql. Click on finish. And now you paste the entire code here. And then what you do is you activate this. Now you have to activate it. So Control S, save it. And then what you have to do is come here. You will see a new file is created, but there's a gray diamond box. If you see a gray diamond box, that means it's an inactivated or inactive repository file. So you right click here and you say activate. So once you activate this, it will tell you activation completed successfully, which is good. Now you have stored the list of SQL statements on the server itself, so that not just you, anybody in your team can access them, provided they have access to this particular package hierarchy, of course. But once they have access, they can come here and they can open this SQL console. So if I close this, okay, I'll come here, I'll just open the SQL console. I will make sure I'm connected to my BW for HANA, HANA database, and I can immediately run the statements. So this is the way you can save your SQL statements, either locally or on the server. If it is something which many people will reuse, better to create on server. But if it is just you are doing some R&D, then you better don't create on server, create it on the local machine. Okay. All right. So yeah, Arpan, I know you have a question. Just let me finish this part and then I'll come to you. Okay. So we have already created the schema. We have already created Mara. Now we will create all this statement, and at one shot you select all and just click on execute. Now it will execute one by one. So you'll see drop table is failing, which is fine. Okay, because we don't have the table. So drop table command will definitely fail, but create table should succeed.
The
And
syntax is incorrect actually. I should have double quotes in create virtual table.
no, it's not required. It's not mandatory.
Oh, okay.
Yeah, it's not mandatory. You can have double quotes, or if you don't have, that's also fine. Okay, so I think everything was successful. So now we should see how many tables. Let's see, we should see Mara, MAKT, T01W, 3, 4, ADRC, 5, AC-DOCA, and 6 VBAP. So we should see 6 virtual tables and 6 staging tables. Okay, so let's go back to our systems. Let's go to catalog. Let's right click on table and refresh. So we should see 6. 1, 2, 3, 4, 5, 6 virtual tables and corresponding 6 staging tables. So they are created successfully. Okay, so this is fine. Now wait a second for VBAP, and let's make sure the data is there. So I'll start with VBAP. Let's see data preview. Okay, so data has successfully come in. AC-DOCA, let me do a quick check. Yeah, data is there. I have 20,000 here. That's why I took a little bit of time. But if you have 200 or 1,000 by default, it should be quicker. Then let's quickly check ADRC, data preview. Yeah, looks good. Mara, which is our main one for material. Let me make sure that has data. Yeah, this we already checked actually before. Then we have MAKT text. This is very important because I want to show you text join, how they work. So we need this. Yeah, that's good. And then finally, I'll just check the plan data, just T01W data is there. Good. So using the virtual tables, we created the staging table and materialized the data. Now you can see here red symbol. This is because the drop table failed, and why drop table failed is because we did not have this. Now if I run it again, this SQL script, everything will run smoothly. Yes, Arpan, questions? You have any question?
Yeah. So as far as I know that in admin console, you don't have this repository tab in admin console.
No, you can
So
activate the repository console. See the way you can, if you don't see the repository view, these are views, you go to window, show view, and if you don't see repository here, go to other and just type repo. So you will see the repository and you can activate that. If you don't see the tab, you can activate it.
So
Okay.
is there any way in from the system tab itself we can save it in the server? Because I know that whatever the package we are creating under content, right? So those packages is again repository objects.
Yeah. Packages are always repository objects. Correct.
Yeah. So can't we save this from system tab itself?
From system, you will be able to create the packages. Yes, for sure. From system tab in the content, you will be able to create packages, right? Yeah. But there are certain objects which you will not be able to do from the system, which are purely repository objects. For example, database procedures. If it's a repository procedures, you have to come in repository and do that. Database procedures can also be catalog procedures, but they are no more recommended. For table functions, for these types of files which I created, virtual table creation SQL, it's better to do it in repository, because you will not find, many times you will not find the option to do that in the systems, because systems mainly deals with the package and the main objects like CVs, but not your database procedures, not your table functions, not your files, the SQL files or other type of files. For that, the better place is repository. Okay. Yes. One more question. I'll take one more question. Anyone?
Devanshu,
Yes.
one question is like in BW, like wherever we start, not let us start with not anything, it is easily traceable by anyone, right? Whoever accesses that. But like you are saving the SQL in some other place, so how can someone understand what is the background and how this table was created in the code? Like we are creating the code in the system. Sorry, we are creating the table in the system, but we are saving the codes in a repository in some other package.
Right.
How someone can correlate where is this code?
Okay, so two questions you asked. First question is how you can check who did this or who created this file. Okay,
right.
That is one traceability. Second traceability is you want to know that where is this code, like if this table is there, where is this code which created this table? How can I locate that code? Right? These are two questions you asked.
Yeah,
okay, let me
either
answer.
you can save locally or you can save in the repository. So if someone saves it locally, then is there any trace where this code is written?
No. If someone is storing it locally, definitely you will not be able to access that code because it's on that person's local machine, right? You will not be able to trace it. But you can trace the details of the table, who created the table, who created the file. If the file is on server, then the traceability becomes easy. Okay, and how it becomes easy is, say for example, I have this file. Now, first of all, in order for you to know that where is that file, of course, there is, from the table itself, you will not know that this table was created via this file. That's not, that traceability will not be there. But in a project, usually there is a naming convention and there is a package hierarchy which is decided in a project, so that an architecture will be there, and that architect will be decide that, okay, we'll have 3 packages or 4 packages. One will be for first level, second level, third level. All our procedures will go here. All our SQL script will go here. So there will be a set hierarchy of packages which have to be defined in a project. You will not randomly create any package and then start creating an object. That does not happen in a project, right? You will not even have access to do that. You will have to follow a proper package naming convention hierarchy and a proper object hierarchy, meaning this object should only go in this particular package. So usually the project will have that, and the developers are aware of that. So in that way, you will know that, okay, if this is a SQL script, then all my SQL script will be housed under this package. You will know that. So that is more of a logical traceability rather than a system traceability. But if they have created things in the system and you want to check that who created this particular table or who was the last one who modified this particular file, then if you create in repository, that is also one of the major benefits of creating things in repository, that it gives you traceability. So for example, I want to check who is the owner of this file and who did the last change and what was the change. So you right click on this and you say show in history. So there is a history view which gets created when you create things in repository. So when you click on this, it will tell you that this guy on this date was the one who did the latest version. Now, if there are multiple versions, you will see multiple rows here with multiple user IDs and date and time, so that you can immediately know that which user ID did the modification on which date. And also, if there are multiple versions, then you can also do a comparison between these two versions. What was the change? What was done between these two versions? That's also possible. But all that is possible only when you create things in repository. Then it will start giving you the traceability. Okay.
Okay.
All right. So it's 9:17 now. So do you guys want to take a break or can I continue? Okay, we'll take a break at 9:30. Okay. So till then, let's continue. I know you have more questions, but please hold on to your questions because otherwise I'll not be able to cover the content. So let me cover the content and then definitely I'll come back to your questions. Okay, so we did the virtual table, we did the staging table. What is the next step? Can somebody please tell me what was the third step we'll have to do?
Calculation.
Correct. The third step is your calculation views. So now our virtual tables are ready. Our staging tables are ready. Now we'll go for calculation views. So where do you create calculation views? You create a calculation view inside a package. So I already created a package. Now you can do that from both the places. From systems, in the content, you can do that. Or from repository also you can do that. The better place, at least my personal preference, is repository. So in repository, I will create a package. I already created this package. Okay. But tell me something, I see some difference between this package type and my new package which I created. Or even this package, there is a double package symbol and there is a single package symbol. Why is that? What is that? Can somebody tell me that?
Sub package.
Was checked out.
Multiple package.
Multiple package, but multiple package, this also has multiple package, this also has further packages. But then why the symbol here is different? Anyone?
Because it is containing
It
the
contains hidden
calculation.
package
That is
also.
structural package. So probably all the calculation view and structures that are created inside the system will be in that package.
Yes, the answer is the package here is a structural package. Package here is a regular package. That there are two types of packages in HANA. One is called structural package. The other one is called regular package. What do you mean by structural package? Say, for example, you have created a package for your entire organization. Say, for example, Walmart is the company for which I am working on. I am implementing HANA. So for Walmart, I created a package called Z Walmart, for example. Now within Walmart, I have several departments. I have my finance department, I have my HR department, I have my sales department. I created package for sales, I created package for finance, I created package for HR. Okay, let me do that. Let's do that. So if I create new package, repository package, Okay, I'll just give the name dot. Always start with dot because it's a parent package name dot the sub package name. So I'll create one for finance. I click next. Instead of German, let me give English. Okay, finish. So finance is created. Now a new guy joined my team, finance team. And I told him that, okay, you have a package, you go there and you create all your calculation views because you are in finance department. Please use the finance package. Don't use any other package. Okay. So what he will do, suppose he forgot about the instruction that he has to only create his calculation view in finance. What he does is he directly created a calculation view inside the main package. So he'll create a calculation view, okay, inside the package. So we'll create some calculation view. Let's give some name, ZCV test, okay, and label is fine. I'll keep it as standard, which is maybe I'll change to dimension, graphical, fine. So he created a CV directly inside the main package. He forgot that he has to create under finance. So technically, can you stop him from doing this? Technically, you cannot stop him. If he forgets the instruction, he can create a calculation view under any package, under main package also. The main package, now the CV is under the main package, not in finance. Finance is still empty. So technically, there is no way you can stop him. So what SAP said, that if this happens, then if people forget, then they will start creating calculation views in multiple places and it will be disorganized. Your entire CVs, your entire objects will be disorganized, not the organization what you wanted. So SAP gave an option to technically stop you from doing this. So that means now let me delete this. Okay. Now what I will do is I will create this particular package, okay, as a structural package. So you edit the package and there is a checkbox called structural package. So click on that. Once you click on structural package, and I'll use this opportunity to also change the language. Click on OK. The symbol changed. The symbol changed, and this means that this package cannot contain any object directly other than packages. You can only create package under this, but not an object. So now if that finance guy comes here and he forgets and he's trying to create a new calculation view here, it will give him an error saying that, sorry boss, you cannot create directly. Your organization has not allowed that. Please go to your particular sub package and create there. This will ensure that the proper organization of your objects happens in the proper package. So technically now you can stop the person so that even if he or she forgets, they will get this error and they will remember, oh, okay, I have to come to finance and do that. So this is the difference between structural package and regular package. Within structural package, you can only create sub packages, and within the sub packages, if it's a regular package, you can create your objects. Okay, that is the difference. All right, so I have made this structural, which is okay, fine. I'll delete this finance thing. This was just for demonstration. Now we have to create what? We have to create a calculation view. So I will create another package just to have a proper organization. Okay, because for SQL script, I created a package. Similarly, I'll create one for CVs also. Yeah, I know guys, you might have questions. Just hold on to them for a few more minutes. I'll come to those questions. Then we will do the calc view. Okay. Calc underscore views. Just giving a short form for calculation. Click on next. Let's change the language. And now this is not structural. I'm not creating a structural because I have to allow people to create calculation views inside this package. Okay. So now calculation view is done. Now inside this, I will right click on it, new calculation view. By the way, analytic view, attribute view are obsolete. Do not use them or do not try to create them. Even though if it allows you, if you are on HANA 1.0, it might allow you. don't create analytic view or attribute view. They are obsolete now. You will only create calculation view. Okay. So I'll give the name ZCV, come on, ZCV underscore material underscore dim. I'm ending everything with dim, meaning all the master data are my dimension CVs, and that's why I'm giving the naming convention of underscore dim. That's one of the best practices to use the naming convention like that. For transaction data, we will use fact. So our calculation view is of type standard. So there are two types of calculation view, standard or time. Here we are just using standard, and graphical or SQL script. Okay, this is also obsolete. Don't use SQL script, always go for graphical. The CV with SQL script has been replaced by CV with table functions. Okay, so don't use a SQL script. And here we will use cube, dimension, or blank. Cube is for your fact, that means the transaction data. Dimension is for your master data. So in here we are talking about material dimension. So we will choose the dimension. Which star join is grayed out, which star join only works with fact, that means with cube. That's why for dimension it is grayed out. You will also have a blank. If you choose blank, that is also type of dimension, but it will have further restrictions that you cannot expose them to analysis for office. The other dimension ones you can expose, but this one you cannot expose to any reporting tool. It can only be used in another dimension CV. So that's the difference between dimension and blank. So we'll use the dimension and click on finish. Because we are creating a master data, that's why we chose the dimension. Now, before I delve deep into it, I will quickly come back to theory about the calculation views so that we know what we are dealing with. Then I will jump back to the creation of calculation views. So what is a calculation view? What is a HANA CV? A calculation view is basically a combination of tables and or views, okay? Database tables or database views, and you combine them or you join them together to form a final structure. So it's basically a combination of different tables and some transformations you do on top of those tables. Like you can concatenate two fields, you can put a filter on a particular field, you can join two tables, you can union two tables, three tables, whatever you want. So it's basically a group of tables, a combination of tables, which creates a virtual structure. So calculation view does not store data. Calculation view is a design time object. It's a virtual model. That's why it's also called VDM, virtual data model. And that is nothing but combining different tables into one virtual model. And those tables, you can have a lot of transformations on that. Like for example, you can write formulas, you can write a calculated column, you can combine them, you can filter them, so on and so forth. So a lot of things you can do with those tables, and you can in a lot of ways you can combine those tables or views. So calculation view is simply a virtual model combining different tables and views. So as an example, you can have a material table, and you can have text in a different table. You can have plant in another table. You will have sales order in another table. So a calculation view can combine all these tables into one particular virtual model, which is a combination of all these tables. And finally, you can expose the calculation views to your reporting tools. So that's what a calculation view does. If you want to compare with BW, it's just like a data source. Data source combines different tables and gives you a final output in a structure. Similarly, a calculation view combines different tables and views and gives you a final structure and the data in that structure. But it is a virtual data model. It does not store data. The data is eventually stored in the underlying tables. Okay. And calculation views are very powerful because they mirror the functionality found in both attribute views and analytic views. Calculation views have replaced attribute views and analytic views. So the functionality from the attribute and analytic views of the past have been consolidated into one view, which is your calculation view. So you don't need to use attribute view. You don't need to use analytic view. This is how it will look like. We will create it. Now attribute views are deprecated. It has been replaced by HANA calculation view of type dimension, which we used. So if you use the type dimension, when you create a HANA CV, then it is basically an attribute view functionality. So HANA CV of type dimension has replaced attribute views. HANA CV of type cube or cube with star join, that has replaced your analytic views. So analytic views in the past were used for transaction data and combining them with the master data. So calculation view of type cube or cube with that star join checkbox has replaced the analytic views. So analytic views are also deprecated. And why they're deprecated? Because these particular views, your attribute view, your analytic view, was running in different engines. Analytic view was using a separate engine in the backend, which was called OLAP engine. Calculation view was executed in calculation engine, and attribute view had join engine. So when you have all these three types of CVs, these different engines were talking to each other and they were passing data to each other. So there was a lot of data back and forth between these engines, which was making things more complex to implement in the backend, and performance was also not optimal. So that's why SAP said that, okay, I'm going to combine everything into one particular view, which is calculation view. So the calculation engine will do most of the task. So as there are a lot of data transfer that may happen among these engines, so some redundancy and the idea to use only calculation view came in, and it will run mostly in calculation engine or SQL engine. Okay, both engines are possible. Either you can use the calculation engine or you can use SQL engine, and you will still have it running in the calc engine while column engine conversion functions are there. So basically, all the functionalities of attribute view and analytic view are combined in a calculation view. If you already have attribute view or analytic view, you can easily migrate them. And SAP has given a very easy way to migrate them, and you can find that migrate option in the quick view. So if you go back here, I'll quickly go to Windows, show view, and you go to other, and if you say quick, so there is something called quick view. So if you enable that, in the quick view, if you scroll down a little bit, there is something called migrate. This migration is for you to migrate the attribute views and analytic views into calculation views. Okay, so this is an easy option SAP has given. So remember this, for master data, we will create a material CV of type dimension. We will also create the same thing for plant. For transaction data, we are going to create for sales order item details, which is VBAP, table VBAP, which will be of type cube, transaction data. And finally, we will combine the master data and transaction data into a cube with star join CV, which will combine your CVs from material plant and the CV from your sales order item detail. And that's what we will do in our overall CVs. Okay, so I'll stop here. We'll take a break for maybe 10 minutes. So it's 9:34. Let's come back at 9:45. And I am here. If you have any questions, you are welcome to stay back and ask questions. But we'll resume our main class at 9:45. Yes, any questions, guys?
Devanshu, Murli here.
Yes, Murli.
How about deltas? You just created the virtual table and the staging table and you push the data. How about deltas? How do we handle those?
Yeah, that's a very good question. So deltas you can handle in two ways. One is if you want to get the latest data, you can truncate and reload. That is one way. That means every time you run the SQL, it's going to truncate the table, truncate all the data in the table and reload the table. That is one way. But that is not an efficient way, because if the volume is huge, then the truncate and reload will take a lot of time. In that case, you have to create a database procedure, and in that procedure, you have to have another table then. So you will create another table, and what you will do is you will create or maintain timestamps for your data load. So for example, you did the data load today. You loaded that today. After the data load, you will put a timestamp in that particular control table. So you have to create a control table which will contain the timestamp for each type of data load. For material dimension, you can have a timestamp in that table. For plant, you can have a timestamp. For AC-DOCA, you have a timestamp, so on and so forth. So you can do that. And next load will now refer to the control table. It will check that, okay, till this timestamp, the data was already loaded. And then it will ask in the select clause, you will put a where condition where you will say that timestamp should be greater than that control table timestamp, and only that record will come into picture. So you have to do certain additional steps if you want to enable delta. The other way, which is an easier way, is SLT. Okay, if you have SLT enabled, then it is a very simple thing. Once you have the SLT configured, SLT itself will give you delta records as soon as there is a change in the source. So here we are not using SLT, here we are using SDA. For SDA, there is no real-time replication. For that, you have to go for SDI, Smart Data Integration. But if you are simply using SDA, you'll have to do this kind of steps, additional steps to store timestamp and then refer to the timestamp and then load the data after the timestamp. But if you have SLT, then triggers will be created, and as soon as there's a change, immediately data will come in.
Okay, got that. Thank you so much.
No
I have a question, Dipanshu.
Yes,
Like,
go ahead.
it might be a dumb question.
No,
So this for creating these virtual tables and staging tables,
yes.
we have created a connection with the S4 system,
Yes.
a remote SDA connectivity.
Yes.
And within that connection, we have created within BW4 HANA application, right? So
hold on. What was the last statement? Within this application, we created BW for HANA?
No. The SDA connectivity that
Yeah.
we have created for S4 system,
Yes.
that we created under BW4 HANA, right?
Yes, that we created in the SDA remote source is created in BW. Correct.
Correct. So in real-time environment, like wouldn't the S4 connectivity be already available within B4?
Yes, correct. 100%.
Then we don't need to create that
No,
connect,
no,
right?
you don't need.
Okay,
You don't need
we
to.
just need to go ahead and use that connection
Absolutely.
to create these virtual tables if they are not existing.
No. Hold on. See, the regular connection from S4 is RFC connection, not your SDA connection. Okay? If you have an S4 already, you will not have to create an SDA to S4 unless you want to transfer data from S4 tables into an external schema in your BW4 HANA database. If you want to do that, then you can either use SLT or you can use SDA. But as long as you are okay to get the data via the regular RFC connection and get that data in the BW owned schema, which is SAP HANA DB in our case, then you don't need to create SDA and all those things. Your regular connectivity, your ODP, that is called ODP connectivity. Your regular ODP connectivity will work, but that will store data where? In BW owned schema. But there can be requirement from client saying that I have some Z custom tables in S4. Bring those tables in an external schema in BW, not in the BW owned schema, Excel schema, and that I will use for some third-party reporting. That is possible. In that case, you have two choices, SDA or SLT. SLT will require a separate license. SDA will not require a separate license.
Oh, in order to bring those custom Z tables from S4 through SLT, it will require a license? Yes, SLT will require a license for sure. And SLT will also require you to install a separate software, which is called DMIS, which you have to install either in source or in target or as a separate box. And that box has to be ABAP server. SLT definitely requires ABAP. But SLT will give you a real-time replication benefit, which SDA cannot give you. So you have to make a decision based on what is your requirement.
And you said SDI, we can do it, right? With real-time replication, can we use SDI?
SDI we can. Again, SDI requires separate license. Okay. SDI will also require Java adapters, DP agent server. So all that additional setup and additional license you have to do for SDI. It's not that simple out of the box. SDI is simple out of the box. Okay. By the way, SDI also uses SDA in the backend. Okay. Don't think that SDI and SDI are completely different tools. SDA is the starting point for SDI. On top of SDA, it creates some Java adapters and then you do the real-time replication. But if you don't want all that additional hassle, you can easily do it from SDA, but you have to compromise with real-time replication. There is no real-time replication with SDA. You have to schedule jobs, and those jobs you can schedule maybe every minute or every 5 minutes. That way you can have near real-time. but not real time.
But Devansh, maybe I have one more question, which
Yes.
is very. Now that let's say you have S4, you have your before HANA and you have your S4, and let's say a similar requirement has come, to display a report, to give a sales transaction report or anything. So in this case, we have both the options, right? We use data sources. Through data sources, we can bring the data and use the info objects,
Yes.
or we can use this option, what you are showing now, by creating these tables and creating a calculation without using any of the functionality of the BW. Still, we can show the report.
Yes.
So in this case, it's purely an architecture call, or how do you decide? Okay, let's say in the team, I may be very good at SQL and I don't know the BW, and I'll know all this, so I start doing this, right?
Yeah.
So
yes. So how do you decide which way to go?
Yep.
Okay. So there are certain benefits with BW which you will not get in native HANA. First point, your delta identification. If you use your BW data sources or your custom data sources or CDS views, delta you can easily identify. The BW data source has delta built in. Your calculation view does not have delta built in. Like the other gentleman asked, how will you identify delta with SDA? You have to do a lot of other extra steps to make sure you identify delta. BW does it very easily and beautifully. For point number one. Point number two, if you want hierarchies, if you want attributes, navigation attributes, if you want easy scheduling with process chains, then BW fares much better than native HANA, because hierarchy handling is not easy in native HANA. You have to flatten the hierarchy if the other reporting tools have to use it. BW hierarchy handling is out of the box, seamless. So you can easily activate hierarchy and use them. Data sources also, they support hierarchy. They have special data sources for hierarchy. So if you want to use hierarchy, if you want to use things like navigation attributes, which are again out of the box in BW for HANA, then native HANA will not be able to give you that. So there are certain things you have to decide which one you want more. If you want hierarchy handling easy, if you want delta capability to be out of the box very easy, and then if you also want easy scheduling via process chains, then you go for BW for HANA. But if you don't want those things, then yes, native HANA can also be your option.
Yeah, Devanshu, one question related to that.
Yes.
Like as you said, smart data is a like virtually we are accessing the data. So how are we scheduling the job? Like in BW we have process chains. So similar to that, what exactly is there?
Access job. So as I mentioned you in the steps here. So the last step will be access job. So what you have to do is you have to create a job which is called access job. So similar to what you created a file here, right? So what you will do is you right click here. Say for example, this is the package where I want to create, and you will say access, and there is something called access job scheduler file. Okay, this file you'll have to create. In this particular file, what is the input you have to give? You have to give two inputs. First, what procedure you want to run. So you should already have a procedure, database procedure ready for the access job. And the second input is the frequency. How frequently you want to run the job. Weekly, hourly, every 4 hours, every 2 days, 3 days, every Friday, every last day of the month, something like that. Whatever frequency requirement you have, that is the second input. Once you create that, and once you activate the access job scheduler file, you'll have to go, the next step is to go to the access portal, access job scheduler portal, which is a web-based portal. There you schedule the job and it will run that database procedure frequently. So all your code should be there in the database procedures. Okay. We'll do that. Don't worry. The last step is access job. So once we do all that, once we create a table function database procedure, we'll create access job also.
Yeah, Devanshu. Just one last question, basic one. On this very screen, the folders, the packages which you're showing, it has like one right arrow, blue arrow, and the other one has stick. So just out of curiosity, what does this represent? This blue arrow?
Good question. Good question. Before I answer, let's see if somebody knows it. Guys?
Yeah, blue is the one which are generated by SAP when you are installing the system or something like that. These are the packages that are delivered by SAP. You have not created it, but it's come by default when you install.
And what about the tick mark?
And the tick mark, this I am not aware.
Tick mark is check out, perhaps. They're checked out and
Correct.
not checked into the repository.
Correct. So both of you are correct. So I'll just add one more thing for the blue part. If you see a blue arrow beside the package, that means it is an imported package. Okay, imported, not created in this system. If the origin of the package is this system, it will not have blue. If it is imported from either SAP, a delivery unit, or via a regular import export transport, then you will have a blue symbol. So that means if you are in a quality system or production system, most of your package will have the blue symbol. Why? Because that is a result of an import from another system. So this is a symbol which will tell you that the package is not created in this system. It is imported from either SAP or your local import. The second thing, tick mark. Tick mark means that it is checked out. So there is a concept, if you are in repository, there is a concept called check-in, check-out. What does check-in, check-out mean? Multiple developers will be able to work on the same calculation view if you check it out. So usually when you do things in the system, okay, multiple developers will not be able to work. They will get a log error saying that this calculation view is logged by some other user ID. But if you work in the repository view, you have an option called check out. What does that mean? That means it creates a local copy for you in your local machine, and you can work in parallel to the other guy. The other guy also, if he has to or she has to work on this particular package, they will also check out this and they will continue working. The moment you activate your particular CV, say for example, you are working on CV1, the other guy is also working on CV1, and you activate it first. So if you are the first one, it will activate and it will create a new version in the repository. So say for example, if I have this calculation view, if you go to history, show in history, which I mentioned earlier, you will see all these versions which are created, and you will see different user IDs. And now you activate it first. So your version will be on the top and your user ID will be on the top. 5 minutes later, the second developer also activated the same CV. He will get a message saying that there is already a version which got activated prior to your version, which is higher version than the one which you checked out. Then it will give you option. What do you want to do? Do you want to merge the changes with the other developer? Do you want to override that developer's changes? Or do you want to discard your changes and keep the other developer changes? So based on what you choose, you can activate your changes, or you can merge your changes, or you can discard your changes. So this is the functionality which is given in the repository view, and this is checking out. So if you just right click on it and remove from client, okay, just click on remove from client. Remove from client means from your local machine, it is removed. And where is it created? Where can you see your local copy? In the path. So you see C users, BW for HANA 3, HANA work. If you go there, the folders will be created with the same naming convention. What you see here, that is your local copy. And when you check it out, your local copy is created. When you remove from client, your local copy is deleted. So you always, the best practice is whenever you come fresh, new day on the work, always check things out and then you start working, so that you will get the latest version, whatever the other person has worked, and then you can continue working. So the checkout, check-in functionality is there, and this check tick mark symbolizes that this package is checked out to your local machine.
So like when we end the day, do we also remove it from the client so that
no, you don't need to. You don't need to. You don't need to remove, but the next day you should again check out, because during the day when you are not working, if somebody else has worked, their changes also you will check it out, and then you will start working on it.
But if we have checked it out and not removed from the client or checked it in, then will anybody else be able to work on it?
Yes, absolutely. They have to check it out. Now, when they check it out, see what will happen is, for example, this CV. Yeah. Okay, this CV will have an active version which will be visible to the person who is coming before you. And your version will not be here. Your version will still be in your local machine. So when he checks out, he or she will check out this server version, not your local version, because your local version is not activated yet. So they will check out their server version, and then they will work on it. And if you have not activated before you left, you just saved it, you came back next day, and if you see that next day somebody else has already activated, there's a new version which is activated, then when you activate, it will throw you a message saying that what do you want to do. So then you take the decision. Okay, but the other person will be able to work. They won't be stopped because of that.
So that means, say I work today and I activated, that means in the server, the calculation view will be updated with my changes once I activate.
Yes, correct.
Okay. So I don't really need to check it in to reflect the change in the server. I just activate whatever object I'm working with and it will reflect in the server as well as my client.
Yeah, but what if you left the work and then the other person did another version activation? Then when you come back next day, you should always check out so that your local copy is now updated with the latest changes.
Latest changes, okay.
Yes.
Hey Devanshu, isn't this a shortcoming of this model? Because if two persons working on the same object and trying to activate at the same time, both might have a different customer introduction, different logic getting updated. Yes. So which version to keep and which version to, overwrite?
Yeah, you have to coordinate with the person, of course. See, in a team, nobody works in silo, right? You have to coordinate with the team member. If you face any error and it is showing you that this person has already a new version activated, you don't want to overwrite his change because you don't know what change he did. So there are two ways. Either you compare your version with his version and see what the change he did. The history version allows you to do that. Or you have to talk to the person saying that, okay, I'm getting this error. Can I know what you have done? And you guys have to collaborate and take a decision. That's a regular project activity.
Actually, same thing is there for SSE as well. Means when you are working in the story, then also some other person can edit that story at the same time and you get the same message like a new version is there. So you want to continue.
In order to fix these kind of issues in HANA 2.0, they have given GitHub integration. If you're aware of GitHub, GitHub does an easy check-in, check-out, but even in GitHub, if there is a conflict, then of course, again, you have to take a decision. So you cannot get away with this. This is a regular issue what every developer team or every team will face. And then you have to collaborate and then you'll have to take a decision.
Devanshu, this check-in, check-out concept is applicable on CV also?
Yes.
Because I understand
on CV as well.
Used for UI5 projects
No, on CV also. On CV also.
On CV also.
Yes, absolutely.
Devanshu, how about the imported repositories or packages? In that, if there is a CV, so only one person can work on it, right?
You will never work on an imported package because you will only work in development most of the time. Imported packages will be in quality and production. You will not do anything in quality and production directly. All right, so let's hold on to your questions. I know you have more questions, and that's why I have a dedicated session. I don't want to derail the topic, so let's continue with the topic, and we'll cater to the questions later on. Okay, so requesting again all of you to be on mute, please, so that we don't have feedback noise in the background. Okay, so the CV concept you understood. Now we will do the material dimension CV. So material dimension means this is of type dimension. So I already created of type dimension. Also, you can see in the view properties, you can see it's of type dimension and it is defined as right. We have session client right now, but I want to change it to cross client. The best practice is change the session client to cross client. What does this mean? This means that if you have a table which has a client concept in S4 HANA tables, we have this client concept in most of the tables, the client dependent tables, which is called MANDT. So the field will be there, MANDT. Now what happens is in S4 HANA systems, you will have in development, especially you will have multiple clients. So someone will be working on 100, someone will be working on 200. There can be a golden client 000. There can be some other clients also. In development, you will find usually multiple clients. Now, if you go to quality or production, there you will have one client. Okay, especially production, definitely you will find one client. Now, if you choose this as session client, that means you are restricting the client here. You are saying that whichever user ID is you executing this CV, go to the properties of the user ID, take the session client, whatever is maintained there, and filter the data accordingly. Now, what if in development the client is 100 and the quality the client is 200? So if you put it as session client, then there is a chance that you will not get data because the client is not maintained probably in quality, or client is not maintained in the for every user ID in quality and production. So that's why, for you to be safe and for you to be immune to that client issue, you always go for cross client. Cross client means doesn't matter whatever client is maintained, all the clients will be shown. Yes, in development, it might result in more records than expected, and that you can filter it out easily with a filter expression. But when you go to quality or when you go to production, you will not face any client related issue, because whatever is a client, it will accept that client and it will show data from that client. So because to make sure that when you transport CVs, you don't face the client issue, always go for cross client. Okay. So now we have this dimension CV, and you can see that because it's a dimension, the top node after semantics is of course the topmost node, but after semantics, the top node is projection node, and projection node comes because we have chosen the property dimension. For cube, the node will be aggregation node, okay, because we are dealing with the transaction data there. So as a best practice, always create another projection node and then you add the table. Don't add the table directly in the top projection node. Always do another projection node and then you add the table. So what is the table for us? The table is STA Mara, because we are talking about the Mara. So it is under catalog, it is under BT2, and we have STA Mara. You can drag and drop here, or you can also from here, you can right click and you can say, no, sorry, not here. Yeah, it's not giving me because I've added. So another way is if I just remove this. Okay. Another way is if you hover over it, there's a plus symbol. Okay. Add object. So you can add objects here and you can just type st_mara. That's also another way. From Debanshu SDA BT2. So you will click there and all of the fields from the Mara table is there. So we'll quickly choose MANDT. We'll choose some fields. Matner. Maybe we'll choose MTART, material type. We'll choose MATKL, material group. Yeah, I think that's it. So there are a lot of fields in the Mara table, but we don't need, in our reporting, we don't need all these fields. So we'll just choose a couple of fields. And then we connect this projection to the top projection. And on this projection, again, in the output tab, there is nothing. Okay, so the important thing is, if you want the CV to show the data, the column should be visible in the output. So I'll just choose everything and right click and I'll say add to output. Okay. Or the other way is, what you can do is, if I just remove this, if you are here, you can also add the columns all the way through all the nodes till top node by saying propagate to semantics. So this is another way. So it's an easier way. If you don't want to go into every node and add again and add again and add again, you can just on the bottommost node, you can select everything and you can say propagate to semantics. It will say selected elements have been propagated. And then you will see output tab already has this, semantic also already have those columns. Okay. Now, can anybody give me a clue or answer that why it is important or why it is recommended to have a projection node added and then add a column and not add directly in this top projection node? Anyone?
in the first projection node, you will only choose what you want, and next time if you want to add more columns, then again you need to directly change this one, right? This gives a visible, I mean, it's like a simple select statement where you are selecting one or two columns and then you want to add more columns. The first projection can, in the first projection.
No, that I can do in this projection also. If I want to add more columns, if I want to delete some columns, if I want to delete this, I can do it in this projection as well.
Filter.
If you want to do joins.
To do joins and.
Yeah, if you have multiple projections in the bottom, then it will be helpful.
No, you cannot create multiple projections to this projection.
Oh.
Somebody said filter. That is the correct answer. The difference between this top projection and this top projection, can you see any difference? Look at the right hand side, okay? What is the difference?
Filters the expression.
Exactly.
Filters.
So this top projection will not give you the option of filter expressions. That's why it is always recommended to have a projection node and then you go for the tables, because now you have the extra capability to do filter expressions, meaning you can filter the data from this table. So that's why it is recommended to have a projection node. Okay, so I'll just go auto layout to make it neat and tidy, making sure everything is there. Yes, MNDT, Matner, METKL, this is fine. Now in the view properties, as you can see, we have dimension, but if say for example, you created dimension and still you are saying that you realize that, oh, no, this should not be dimension, this should be cube. You can always come here and change that. It's possible. So don't think that you have created dimension, you cannot change it to another type. You can always come and change it here. Hierarchies, if you have any hierarchies, you can create it. HANA allows two types of hierarchies, parent-child hierarchies and level hierarchies. So you can create any one of them. And if you have any parameters or variables, this is also important and this is helpful for restricting the data and also using the user input in your calculations. If you want to do that, then you have to create parameters. And if you want to restrict the data, you can use variables. Now, very common question is, what is the difference between input parameters and variables? Okay, and you have to know this. This is very important. The main difference between input parameter and variables is input parameter can restrict the data right from the bottom, right from the table level. The first table or the first few tables which you are using, input parameter will allow you to restrict the data right at this level, even before it goes up. But variables cannot restrict the data until everything comes to the top node, all processing has happened, then variable can filter the data. But input parameter has the capability to filter the data right at the bottom. How? Let's see. So let's create an input parameter. Okay, I'll just give the name here, IP underscore material. Okay, and this is for material, and parameter type can be either direct, can be a column derived from table, static list derived from procedure. Direct means user input, so you don't want to give any F4 help value. It is direct and user will give the input. Column means it is still user will give the input, but now user can have an F4 value help, meaning user doesn't need to know what the material number is. They will just click on that F4 value help and they will get the list of the values. So if you click here, okay, column, then you will see that already this is value help. Okay, value help means to help the user see the list of material and then he or she can choose from that. So that's called value help. So when you click on column, automatically this particular CV itself will come as a value help for the particular column material. Now, if you select derived from table, then user input is not there. You have to derive this at the back end. Automatically the value will be derived. Okay. If you want that to be overridden by user input, there is also a field, but by default, the user will not get the option to choose. It will be auto derived from the backend table. Static list means you want to give manually you want to type the entries for the user to choose. Then you can choose static list. and you have to provide the values here, and those values he or she will be able to, the user will be able to see when the input help is chosen. And finally, derived from procedure, meaning again, user input will not be there by default. It will be auto derived by a procedure or a scalar function in the backend. But if you want that value to be overridden by user input also, then you can choose the input enabled as well. So in our case, we will choose the column because we want the input help, but you should not choose the CV, which is the current CV for the value help. By default, SAP will give you that option, but that's not a good option because performance wise, it is not recommended. If you leave it as it is, and if you just choose the material from here, what you are saying is execute this calculation view again for the entire calculation view will be executed and material number will be fetched and shown to you. And then once your user has chosen the value, again the calculation view will be executed. So in this case, calculation view is getting executed twice. Once to fetch the values for the user and once after the user has provided the input. That's why this is not a good option. When you choose column, always choose a table which stores the value. So in our case, it is STA_Mara, okay, from Dibanshu SDA-BT2. And then you choose the column, which is Matner. Now what will happen? It will not execute the CV for the value help. It will just go to this table and then fetch the column Matner and show the value. So your CV will not execute at the time of your input parameter. So please remember that from a performance standpoint, the default option is not a good option. Okay, we'll click on OK. Now input parameter is done. Now see what will happen. If I go to my projection 1, here, if I say expression, if I say open expression, now I want to filter the data, whatever user input has been provided, I want to filter my records based on that user input. So you can see what I have columns here and I have input parameter here. Do I have a variable folder here? No, I don't have a variable folder here, meaning I cannot use variables to restrict my data at a table level. Don't think that I have not created the variable, that's why the folder is not there. Even if you create a variable, the folder will not be here. The folder is only there for input parameter. So I'll just say material equals to input parameter. $, input parameter $, that's the syntax. So now I have restricted my data right from the bottom to come only those records, to filter only those records which user is requesting for. And then all the processing, everything will happen based on the user input. So control F3 to activate. Okay, there is a failure, guys. Let's see the failure. So double click on this and it says user is not authorized. Why am I getting this error? Anyone?
Guys, after creating the schema, you need to give the
required.
I guess after creating the schema, you have not given the privileges to the sysbic. No? You have to execute a statement, right? Grant select schema on the sysbic something, so that you can create the calculation views on top of the.
Correct, absolutely. Did all of you understand this point? Okay, let me explain. So user is not authorized. Which user this error is talking about? This is not the user which I am using, BW for user. It is referring to a system user. And that system user is called, let me write here. System repository user for HANA objects. Okay. So there is a concept you have to know. There is a backend user, backend repository owner, you can say. That guy's name is _sys_repo. Okay. Sys repo. In short, we call sys repo. Whenever you activate a calculation view or a procedure or anything which is repository object, this is the user ID in the back end who is activating on your behalf, the repository owner _sys_repo. If this guy does not have access to the schema and the tables you are using in your calculation view, the error message will come up saying that user is not authorized. That means they are saying sysrepo is not authorized to activate. Why? Because sysrepo has no knowledge of this new schema which we created. So if the sysrepo does not have knowledge, and by the way, when you create a new schema and you create new tables, by default sysrepo does not know about them. You have to explicitly tell sysrepo that, hey, I have a new schema and I'm granting you access to this schema so that you can easily activate the CVs. So you have to explicitly grant that privilege to sysrepo. Only when sysrepo knows about the schema and tables and in that schema, then only the sysrepo can activate your calculation views. So what you have to do, come back to your SQL statement. Okay. Let me close the unnecessary ones. Okay, I'll just close this as well. Let me open the file from here. So we'll go to see the Banshu, this calculation view, no, not calculation view, SQL script. Okay, let's open SQL script. Let's connect to the HANA database for BW. Now what I will do is, after creating the schema, I have to say grant select, grant spelling is wrong, grant select on schema. Which schema? My new schema which I created, because I don't want to give individual table level. Individual table also you can give, but I want to save that effort and I want to give the entire schema access to the person, to the sysrepo. Grant select on schema to _sys_repo with grant option. Okay, this is also important. You are also granting sysrepo to grant this to others, and this is required because in the backend sysrepo also talks to sysbi and also talks to sysbic. That's why the sysrepo should be able to grant them also the necessary privileges. That's why with grant option is required. So this is the syntax to allow sysrepo the ownership, or the at least the select privilege, not the ownership, the select privilege on your particular schema. So you do this, execute, successful, come back to your CV, and now you try to activate. You can activate from here, or I use the shortcut, keyboard shortcut, Control F3. And now it says completed successfully. So now sysrepo knows about this schema and the tables, and it can activate your CV successfully. Now let's do a data preview. So when you do a data preview, you will see that now it's asking for an input parameter. Why? Because I gave that input parameter, and now if I choose the input parameter, this is the value help I was talking about. When you click on this value help, this data is coming from which table? The STA Mara table, which we gave as the value help. So if I just choose this, I'll say okay. And if you go to raw data, only that particular material will come up. So basically I am using input parameter to filter the data right at the table level, and then I am restricting the data, and all the processing will happen on the filtered data. Variables, if you create, then you will not be able to filter at this level, only at the top level it will be filtered. So that's the difference between an input parameter and a variable. Another difference is that input parameters can be used in filter expressions. So if you want an expression saying that if material is starting with 40, then only you do some other calculation, otherwise you do something else. If that anything you have to do with the user input, you have to do some calculations based on user input, then input parameters you can use in the filter expression. You cannot use variables in the filter expression. So that's another important differentiation. Okay, so that's the basic difference between input parameter and variable. But there is a benefit variable provides which input parameter does not provide. What is that benefit? So let me quickly do that. So instead of input parameter, we'll quickly create a variable. Okay, create a variable. So I'll close this. I'll show you again. So once you click, instead of input parameter, now we'll create a variable, and I'll say var material. Okay, I'll just give material, and here I have to choose the attribute. Okay, the value have for table. You can choose the CV here, or you can choose that sta_mara, which is from my table. Okay, and then Matner. And now you can choose single value, interval, or range. Okay, so this is another flexibility which is provided out of the box for variable. This we did not see for the input parameter. Input parameter can have, I think, multiple single values, but interval, range, all these things are not there for input parameters. So I will choose single value for now. Default value don't want. I want to apply this particular variable to my Matner. Okay. Now this applicability is at the top end. It will not restrict the data at the table level. Only when everything comes up, it will come and filter the data. Now I'll delete this material for the time being. Okay, so I'll click on remove. You want to remove? Yes, I want to remove. Once you remove it, you also have to come to the expression and make sure it is gone, because your input parameter is no more there. Now you see I created variable, but still I am not getting any folder for variable. So I cannot restrict my data based on a variable. Okay, now I will activate it, Control F3. Okay, activated successfully. Now I'll do a data preview. Okay, now once I do data preview, I have an option for the same material, and the same material will come up from that table. But if I leave it blank, what will happen? Anyone? What if I leave it blank and execute? Will I
Every
get data?
Will come up. All data will come.
All data. Because you did not select mandatory here, I think.
It doesn't matter. Even if I select mandatory, if I leave it, mandatory, I have to give it value. You're right. But even I think in mandatory, you can leave it as blank. Let me try that once. Okay. Let me make it mandatory. Okay. And then F3. Let's see. Now, if I leave it blank, it will say one of the mandatory variables has not been entered. Yes, you're right. So if I make it mandatory, yes, I have to enter the value. But if I don't make it mandatory, say if I remove the mandatory clause, okay, I just want to show you the difference between input parameter and variable when you don't give a value. Okay, so I'll leave the blank for now. Now, if I execute it and if I leave it blank, will I get data or not?
Yeah, we should get data.
Yes, we will get data, and we will get data for everything, all material, we will get the data. Okay, so blank means give me everything for a variable. But what if I create an input parameter? So I'll go back and I will remove this for the time being. And then I will quickly create an input parameter. Same thing. IP_material. Okay, I'll give the column. I'll not make it mandatory. That's fine. I'll choose the table, which is st_mara from our schema. Then we will give the column value as Matner. Okay, no default value. I don't want that. I'll click on OK. Activate. Okay, activate successfully. Yes. Now you do data preview. And now if I leave it blank. Oh, wait a second. Maybe it was not mandatory.
You have to map.
Yeah, I haven't mapped it. Correct. I haven't mapped it. So I have to map it here. Either I can do filter here, or I can do expression. The recommended way is to go to expression. Okay. And I'll have to map quickly for material input parameter. Okay, let me bring it up. Okay. and then activate. So unless you map the input parameter, you will not get the prompt. So that's another difference. So let's see if the job log is then. Yes, activated. Now let's quickly do the, now if I don't give anything, will it bring data or not?
No data will come.
Why?
Because that material is now equal to blank and we don't have anything equal to blank in the
Exactly,
mark.
exactly. So that's the difference. So now if you execute it, you will not get anything. The reason is because the blank is taken literally as blank for the input parameter, but the blank for variable is taken as give me everything. So that's also one of the differences between input parameter and variable. Okay.
So if we need to select all values, then
if you need to select all values
along with the input parameter.
If you need to select all values, see in input parameter you will have single value or multiple single values. I don't know if star will work. Let me see. Maybe the wildcard characters. I doubt it though, but let's see. No, it doesn't work. So
can we do unequal, not equal, not equal?
No, there is no not equal. So if you execute this, there are only two values, equal or not null. Or is null, sorry.
Maybe we could use match statement to bring in everything.
Yes, we can use match. See, you have to do additional steps, meaning in the filter expression, you have to use some functions, and match function is one of the function you can use. Yes, if you give star here or if you give blank here, you can still handle the blank and read it as everything and give everything, but you have to do certain steps or additional functions you have to write in the SQL expression, and then you can get that.
Or no input parameter is required.
No, input parameter, I'm saying with the input parameter. See, without input parameter, anyways, you are getting everything. There is no restriction. But when we do input parameter, and still if you want to select all the values, then you can give star, and in the match function, it will match the star as, and it will give you all the values. So those additional steps you can do, the configuration you can do in the SQL expression to make sure you are handling the blank or the star. But otherwise, if you don't do that, then it will literally take it as blank and it will not give you any values. Okay. So now our material dimension is ready. Okay. We have one input parameter of IP material and we activated the material dimension. And now I want to show you, let me activate this one also. So because we made the change, so we'll save it and then we will activate this. So every time you make a change in the SQL script, make sure you activate it if it is on the server. Okay, so material dimension is done. What was the next requirement? Let's go back to our requirement. The requirement was material dimension, plan dimension, but in material dimension, we need text as well, right? So we don't have material text, we only have the material. So for text, we had one table, right? What is that table name? MAKT. MAKT will give you text. So let's add MAKT now. Okay. So again, to add a table, you will go to projection node. You will click on add and you will just say MAKT. And MAKT might be there in multiple schemas. The one which we are interested in is this one, BT2. So we'll click on OK. Oh, this is a virtual table, VT. So we are not, we don't want virtual table, although it is possible. As you can see, it accepted the virtual table. But I want to replace this with the staging table. So if you already have a table and say, for example, you want to replace it, you can right click on it and you can say replace with data source. So if the structure is the same, then you can easily replace it. Or if the structure is not same, then you have to do some mapping. So I'll just say MAKT, and this time I will choose STA MAKT, not VT MAKT. Okay. So STA MAKT, which is fine. So now I have STMAKT, and same thing I'll do here. Select everything, add to output, and then I will. Okay, so this is done. So we have MANDT, Madner, SPRS is language, MATKX is, and MATKX and G are the text description. So let's quickly do the data preview of this particular table. So you have client, you have the material number, you have the language, you have the description short and description long. Okay. So what we will do is, we will take MATKX because this is a better description. This is all caps. I don't want that description. I just want a simple description. So I will choose MATKX. I will remove MATKG. So I don't need MATKG, which is fine. So it is removed. So I have MATT, matters, process, and MATKG. Good. Now I have to join with Mara. So in order for me to join with Mara, I will go for join node. Okay. So when will you use join? When will you use union, projection? Projection we already see. It's basically if you want to select a subset of fields from a whole list of fields, you will go for projection. And also if you want filtering and all, you will go for projection. You will go for join node when you want to join two tables based on a common field or a list of common fields, and you want only few fields from the other table. So in the one table you have 10 columns and you just want two other columns from another table, and there is a common columns between the two tables, then you will go for join. You will not go for union. When will you go for union? You will go for union when you don't want just two columns from the other table based on a common condition. You want to append data. So you want to combine data, and the structure is more or less the same for the two sources of the union. Okay, the structure is the same, and you just want to append data or combine data. Meaning, say for example, we have actual data and we have planned data as an example. Both have same fields. Say the structure is more or less the same. You just want to add the planned data in addition to the actual data. In that case, you will go for union, because you're not, the scenario is not that you just want a couple of fields from the other table based on a common condition. That scenario will mandate join. But if it is combination of data, it will be union. Okay, and then you have some rank node also. If you want to filter based on the rank function, which is a window function, so you have the rank node. And then finally, you have aggregation node. If you want to sum up some of the key figures or some of the transaction data like quantity or amount or anything which can be summed up, if you want to have that aggregation behavior, then you will go for aggregation node. So these are the different nodes and the purpose. So in our case, we just want the text from the MAKT table. We want everything from Mara. We want just a couple of fields, which is language and text from MAKT. So we will go for join node. So now already I have this added here. So there are two ways. Either I have to remove this and then put the join in between and then do the join, or if you already have this and you don't want to disturb it, you can drag the join on this arrow. The arrow will become orange. Put it on that and it will ask you, do you want to insert this node between these? You will say, yes, I want to. And automatically HANA will take care of the remaining fields. Whatever fields have to be propagated, those will be there. The join will be added. So that's a handy way, a quick way to not disturb your existing flow and still add new flows. Now for projection 2, I will add, but before adding, I just want to make sure I rename it properly. So I will do it MAKT, so that in the join node, I can easily identify which node is depicting what. And here I'll give Mara. So you can rename the nodes. So now I'll connect it here. Okay, with the join, do a auto layout. So now I have Mara, I have a input parameter filter based on Mara, I have MAKT. Now I'll go to join. I'll just minimize this so that I have more screen real estate for my development. So I have my join one, and now I have two tables here, Mara and MAKT. On the left side there is Mara, on the right side there is MAKT. I want everything from left side and I just want few fields from right side. That is called left outer join. Everything from right and matching records from the, everything from left and matching records from the right table. So what I will do is I will right click in the empty space here and I will say create join. Once you go there, then you have to select your left table and right table. So for left table, I will choose Mara. For right table, I will choose MAKT. And what are the common fields? Client is a common field. So drag on top of each other, it will create a join. And Matner is a common field. So I have MANDT and MATNER. So based on the material, I want the language and I want the description. By default, the join type is referential. You change it to left outer join, and don't worry, I will explain you what is the difference between all the join types. But right now, for our requirement, we'll choose left outer because we need everything from left and only matching records from the right. Dynamic column, we don't need it. Dynamic column is required when we want a window function kind of a behavior, and also if you want aggregation before calculation, like your summation or aggregation, aggregation before calculation, then you go for dynamic join. But we don't need it right now. Cardinality. So cardinality means if you know the cardinality, then you should provide. If you don't know the cardinality, then you should keep it as blank. Usually we will know the cardinality if it's simple tables, like we know that for every material there will be one text description, right? Or for every client and material there will be one text description. So it will be n:1 because n records here, every record here will find one record here. So you can give the cardinality. But if you are not sure, right, let HANA handle it. HANA is smart enough to profile the tables and know the cardinality by default. What is the correct cardinality? So you can keep it as blank. I usually keep it as blank. Okay. Now I want the text from here. So to get the text, I will have text in multiple languages. I can have text in English language. I can have text in French language, in German language, in Spanish language, etc. But I want the text to be dynamically filtered out based on the user ID. So say, for example, I am logging in HANA and I'm executing this CV. My language is defined as English. So I want to see English. But if my language is defined as German, I want to see German text automatically based on my user ID. Then if you have that kind of requirement, you go for something called text join. So what does text join give you? The text join will give you the benefit of filtering the text automatically based on the language for the user ID, whoever is executing this calculation view. Okay. And if you choose text join, you have cardinality is always 1:1 by default. And then language column, you have to choose. This is a mandatory field. In this case, our language column is SPRAS. So with this, I will click on OK. Okay, you can see the symbol is text join and the cardinality is 1:1. And we will quickly make sure we have selected SPRAS and MATKX here in the output. Go to projection node, make sure it is also selected there. We could have used a shortcut also, propagate to semantics, but I'm doing it every node here. In semantics also make sure it is added. Your SPRAS and MATKX, yes, it is added. Now we'll click on Control F3 to activate. Okay, and it is activated. Now I'll show you the benefit of text join. So first, let's profile the data quickly for the MAKT. We'll take TG10, for example. We'll do a quick filter on TG10. Now you see that TG10 has language English. Okay, let's filter for client 200 because client 200 is a main client for S/4HANA. So for 200, it has two text, or it has two language text. English language text which says trade goods 10 PD third party, and German language, D denotes German, Hanselware 10 PD Streck. Okay, so this is a German language description, this is an English language description. So let's see what language comes up, what description comes up if I do a data preview. So I'll do a data preview. Okay, material, I'll say TG10. You can directly type also if you don't want to choose from the drop down. If you know the value, you can type, and I'll say okay. I'll go to raw data and I will filter on 200 client. What came up? Is it English text or German text? This is German text D. Why German text came up? Why English text did not come up? Because my user ID with which I am executing this has German language. Now let me change the language. Okay. So you can go here. You can right click on your, no, not here, I think in the systems. You can right click here on the system. You can go to properties, go to additional properties, and there is a locale. There is something called locale. It is German here. So click here. I will change it to English. Let me change it to English, United States. Okay. Apply and close. Close this data preview. Do it again. Data preview. It's asking for material. I'll give TG10. Okay, click on OK. Go to raw data. Go to 200. And what is the text now? English language text. So this is the usability of text join. Based on the locale of the user ID, you can see that different language text is automatically filtered. I'm not giving any filter. Automatically system is based on my user ID is filtering. So this is what is called text join. Now my question to you is, what kind of join is text join? Is it inner join or a right outer join?
Inner join.
Inner join. Anyone else?
Left outer join.
Left outer join. Oh, I didn't even give that option. Okay. Anyone else? Yes, you are correct. It is a left outer join. Please remember, text join is always left outer join, meaning if you don't have text on the right table, you will still see null coming up, but everything from the left table will still show up even if you don't have matching records. You will still see null. So it's a left outer join. So it's not that the data will be filtered from the left table. Left table will still give you everything. But this is the usability of text join. So before I go further into it, I know we are over time, but just bear with me for a few more minutes. What I want to discuss quickly is the join types in HANA. Okay, what are the different join types? So I already have this Excel. This Excel is already placed in the material folder. Okay, so let's quickly discuss the join types so that you are very clear on the join types, and then we will further develop our CVs so that you will understand the join types. So to understand join types quickly, I have mocked up sample data. We have table A, we have table B. Table A has ID and flag value, yes, no. Table B has same ID and text value, HANA, BW, ECC, S for HANA, BW for HANA. Okay. And common column, what is the common column? ID is the common column. So now if you do an inner join between these two tables based on the common column, what will happen? Only the IDs which are there in both the tables, that means 1 is there, 2 is there, 3 is there, 4 is not there, 5 is not there, 6 is not there. So common IDs are 3. So only 3 records will come up. And this is the Venn diagram symbol for the inner join. What if it is a left outer join? Left outer join means that everything from left and matching from the right. So in this case, if you do that, everything from left will come. So 1, 2, 3, 4, 5 will come. 1 is there, yes, HANA will come. 2 is there, yes, BW will come. 3 is there, ECC will come. 4 is there, no. So null will be returned from the join. 5 is there, no, null will be returned. So doesn't matter if the right side has the value or not. Left side, everything you will get. Right side, only the matching ones, not matching ones will have null values. This is called left outer join. This is the Venn diagram. Right outer join, same thing, you just reverse it. So everything from the right, 1, 2, 3, 6, 7. 1, 2, 3, 6, 7. Flag everything, Y, N, N. But 6 is not there, so null for 6. 7 is not there, so null for 7. But text is there because text is coming from right side. So everything from right side, this is everything from right side, and matching from the left side. This is called right outer join. Then we have full outer join. Full outer join means everything from right, everything from left, and wherever it is not there, nulls will be returned. but you will get all IDs here. 1, 2, 3, 4, 5, 6, 7. Matching will have values, otherwise null. Matching will have values, otherwise null. This is called full outer join. Then we have something called text join. Text join, as you can see, it is a left outer join. Please remember that. And it will have all the values from the left table and matching one from the right table, exactly same as your left outer join, with a difference that text will be automatically filtered based on the locale of the user who is executing the text join. Then we have something called referential join. Referential join behaves in 3 different ways. That's why I've given three different boxes. First is your referential join, no column from right table is requested and cardinality is mentioned. Cardinality plays an important role in referential join, guys. Okay, so you have a scenario where everything from left table is requested. That means ID and flag is requested. Text is not requested in the main output, but cardinality in the join is maintained. In that case, it will act as a left outer join. Second scenario, columns from left and right is requested. It will act as a inner join, irrespective of cardinality is maintained or not maintained. If we have values or columns requested from both the tables, it will always act as an inner join, referential join, okay, automatically. Then the third scenario is only columns from left side, but cardinality is blank. You have not mentioned cardinality, okay? Then also it will act as an inner join. So based on whether you have maintained the cardinality or not, and you have only selected the left side values, you will get either inner join or left outer join. So this is important for you to understand. With referential join, cardinality plays an important role. And there is another type in HANA which is called cross join. Cross join is Cartesian product, n is to m. Meaning, if you have 5 records here and if you have 5 records here, total 25 records will be created. This is called cross join. Okay, and there are scenarios which will mandate us to do a cross join. Say for example, you have a right hand side table and left hand side table, and you want to say paste a common flag to all the values of the left side table. Then you go for cross join. That means everything will be multiplied, like it will be a Cartesian multiplication, and you will have 25 records, meaning everything from right multiplied by everything from left. So if you want to visualize this, 1 by HANA, 1 by BW. So 1 is multiplied by all of them, then 2 all of them, then 3 all of them, then 4 all of them, and 5 all of them. So this is what is called cross join. Okay, so this is another special join which is there in HANA. I mean, it is also there in SQL. It's not a new type of join, but it is possible in HANA. And how you do cross join in HANA? Can anybody tell me how you achieve cross join in HANA? Like here in the join, okay, I didn't see anything called cross join. There is no cross join. Then how do I achieve cross join? Anyone?
Full outer with cardinality n into m.
It will still be full outer. It will not be a Cartesian product.
I guess if you don't specify a join type, it would take as a cross join.
You don't. There is no option of not specifying join type. There is no blank here.
There is no need.
Referential with n to n.
Don't map.
There is no need to map.
Correct.
Between tabs.
Exactly. If you don't select this, if you don't combine the common columns, okay, don't map it. Put a join node. Put 2 tables here. That's it. That is nothing but your cross join in HANA. Okay. So these are the join types in HANA. So now we did a text join. Say for example, I'm just ending in 5 minutes, 5 more minutes, guys. So if I don't want text join, say for example, okay, I'll go here. I will still keep, I want to keep it as left outer join. Okay. Cardinality 1:1 is fine. Otherwise, I can keep it blank. Left auto join, no dynamic join. Okay. And I still want the functionality of text join without giving text join. Is there a way? Can anybody tell me how can I achieve the functionality of a text join without selecting the text join?
Left outer join.
Maybe then you have to give sparse in the parameter and choose the language so that you will get the language what you want.
Yeah, but I don't want any additional parameters. Then you are asking user basically. No, I don't want to ask user, but see what did text join do? Text join automatically did it. I want this CV to automatically do it for me.
Getting the user locale and filtering MAKT.
Again, you are writing an expression, you're saying.
Yes.
Okay, let's do that. So if I go here in the expression, what do you want to write in the expression?
So let me, I need to check if we can.
No, you're right. You are going in the right direction. But what is that expression which will allow me to have text join without the text join?
So
we need to find an example from where we will able to find the user language.
Yeah, how will you find user language?
That is something.
Input parameter.
Input parameter is for material. No, I don't want to. That's what I'm saying. I don't want. See, input parameter means, okay, then again you will write a procedure, and that procedure will, you will write a code to get the user locale, and then you will filter. That's what you're saying, right?
Column sparse equal to maybe some function is available.
Functions.
Okay, so there is a default system given variable. Okay, remember this. There are some standard default variables which are processed in the backend. One of them is $client $. Another one is $language $. So what you have to say is my column not matter. Pras is equal to $, language $. It will show you red. Okay, it will not accept this, but don't worry about it. You can ignore the red part, meaning it is showing as error. That's fine. Click on OK. Activate this guy. It will activate successfully. Okay, even though it is showing red, it is activating successfully. Now, what is my language? English. Okay, let me change it to German again. So I'll go to properties, I'll go to additional properties, I'll go here and I will choose German. Apply and close. And now, if I execute this data preview, let me give any material. TG10 it was, right? TG10. And now for 200, it is showing me in German language. So this is another way, if you don't want to use text join and want to have a simple left outer join and the functionality of a text join, then you have to go and use the system default standard variable of $, language, put it as pras equals to, don't worry about the red symbol, it will still accept and it will give you the same functionality. That's another way. Okay, so with that, I'm going to end this session today. Next session, we will continue. We'll create plan dimension. We will create the sales, which is the fact. And finally, we'll create the cube with star join. And then we'll also show you the table function and database procedures. So let me stop the recording here. I'll stop.